Today we will discuss system development life cycle. There are certain steps to develop an information system, or if there is, if you want to upgrade previous old system with a new one, and there are certain steps we have to follow. We call those steps as system development life cycle. So before I discuss with you one by one all the presentation slides, I am going to explain you briefly what actually system development life cycle is and how its different phases works. So basically, the system development life cycle frameworks provides a sequence of activities for the system designers and developers to follow. It consists of set of steps or phases in which each phase of the SDLC system development life cycle uses the result of the previous one. A system development life cycle adheres to important phases that are essential for developers, such as planning, analysis, design, and implementation of the system. And explain in the section, I will one by one discuss with you what there are different two different models. A number of system development lifecycle models have been created: waterfall, fountain, spiral, build and fix, rapid prototyping, incremental, and synchronize and stabilize. The oldest, these are different models. One is waterfall, fountain, spiral, build and fix, rapid prototyping, incremental and synchronize and stabilize. The oldest of these and the best known is waterfall model. So this is the waterfall model in which once you completed the first step, then you go for the next step. So a sequence of stages in which the output of each stage becomes the input for the next. These stages can be characterized and divided up to in different ways, including the following. For example, you can see the preliminary investigation, the system analysis, the system design, the system acquisition, system implementations, and system maintenance. After every step, you get an output, which will be the input for the next system. You can see there are certain outputs of every step. So preliminary analysis or investigation, the objective of phase one is to conduct a preliminary analysis, propose alternative solution, describes cost and benefits, and submit a preliminary plan with recommendations. Conduct the preliminary analysis, you need to find out organization objectives and the nature and the scope of the problem under study. Even if a problem refers only a small segment of the organization itself, then you need to find out what the objective of the organization itself are. Then you need to see how the problem being studied fits in with them. Propose alternative solutions. In digging into the organization's objective and specific problems, you may have already covered some solutions. Alternate consultants. You can also study what competitors are doing with this data. You will have three choices: leave the system as it is, improve it, or develop a new system, and describe the cost and benefits of the new implementing a new system. So all these things you have to do in the preliminary analysis. Then system analysis. In system analysis and requirements, define project goals into define functions. You have, first of all, you have to define project goals into defined functions and operations of the intended application, and analyze end users information needed, that what is required for the end user so that he can perform the activities he or she can perform. Then we have to see the system designs. It actually describes the features and the operations in detail, including screen layouts, business rules, process diagrams, pseudocode, and other documentation. Then you have system acquisition, that is development, integration, and testing phase. In development phase, that is acquisition, the real code is written in this phase. Integration and testing brings all the pieces together into a small testing environment, then checks for the error, bugs, and interoperability. Then the system implementation, except installation and deployment. That is the final stage of initial development where the software is put into production, implementation, and runs actual business. Then we will see if any sort of a maintenance is required. So in system maintenance phase, what happens during the rest of the software life? Changes, corrections, additions, moves to a different computing platform, and more. This is often the longest of the stages system development. So these are certain steps. This is the summary of the whole system development life cycle, which we actually do while designing or updating the previous available system. So preliminary investigation. What happened in the preliminary investigation? A feasibility study is performed to assess whether or not full-scale projects should be undertaken. Documentation. You have feasibility report after preliminary analysis, that if whether the project is possible, what are the possibilities we have, what are the alternatives we have, cons, contain is finding on status of existing system, and the benefits and feasibility of changing to a new system. Includes system analyst recommendations regarding whether or not the project should move on to the next stage in the SDLC. We have to keep going with the previous, or what steps that we need to take. So all this happens in the preliminary analysis. Then we have system analysis, examines the problem area to determine what should be done. Data collection, gathering information about the system, organizational chart, observation, interviewing users, etc., that what they are willing to, how, what type of outputs and what type of inputs they actually they have their demands. So then we have data analysis, analyzing information to determine the effectiveness and efficiencies of current system and our requirements for the new or modified systems, that what new things they want to see in the form of the uh, in the form of output, in the form of input. So how the end user wants to modify new system with respect to the previous one. Entity relationship diagrams, ERDs, and data flow diagrams used to model the entities in a system and the flow of data within the system, provides a visual representation of the data, movement in an organization, decision tables, and decision trees. Useful for identifying procedures and summarizing the decision-making process of one step of a system. So this is how. Then we have, if we talk about for any specific business process modeling notation, so a graphical standardization notation used to model business processes, used to model the business process used within the system, designed to be understood by all individuals involved in the system. Those who are going to work on this system, express the process graphically using diagrams similar to flowcharts. For example, class diagrams and use case diagrams. So this is the customer, this is the class diagram used to illustrate systems that are based on the concept of objects. So for example, customer attributes, we have customer class name, customer attributes, name, address, telephone, email, password, credit limit, balance. Then methods, that change telephone, change address, change email, change password, make payment. That is class diagram list the attributes, methods that all instance in the class. In this case, the customer class possesses. This is actually a need, that this is the customer, he want to place order, update information, make payments. So use case diagram, class, and use case diagram, these tools are frequently used to model object oriented systems. This is complete a diagram which describe the class diagram and use case diagrams. Use case diagram list a users of the system, in this case a real customer, and its use cases, the action the user may take is actually explained, that what you want to do, place order, update the information, make some payments, etc. Documentations, diagrams, tables, trees, and models consist of any instrument used for data gathering. The resulting diagram, trees, models, and other tools used to summarize and analyze the data. Questionnaire, we will going to fill up some questionnaires, interviewing questions, diagram, models, etc. This is how we take the input so that we can design and develop system design. Now specifies what the new system will look like and how it will work, so that end users, it will give the, it will fulfill the demand of the end users who is going to work on this system. Developing the design and specification for the new system. Model of new system is developed. Diagram can include data dictionary, describes all data in a system, data flow and or class diagrams of the new system, user interface UI designs, that what type of user interface, how you do it so that it will be interactive and attractive for the end users. For example, you can see papers design can be sketched on paper, digital design can be created using a variety of software programs. So you can see new students entry form, name, city, from where he came. So this is how they want data entry forms can be visualized user interface, so that they can input the data in this by using this software in order to save or maintain the records in the database. So this is user interface design and are created during the system design phase, so that if something more is required to the user, so that he, on the recommendation and on the demand of the end users, we can add some more features. Cost benefits, considering both tangible and intangible benefits to determine if the benefits of the new systems outweigh the cost. Documentations we do, system design and specification developed during the system design phase consist of all the documentation necessary to illustrate the new system which is required. System acquisition. The system analyst determines whether to obtain the necessary hardware, software, and other system components. They make or buy a decision that what components are required to purchase in order to integrate in this particular system, so that it fulfills the requirement of the end user. So determining if the software needed will be purchased from a vendor or developed in-house, as they have their own programmers and they have the capability to develop and this particular software within the in-house. They are not going to outsource that thing. So if developed in-house, software to be developed moves into the program development process. RFPs and RFQs. RFPs is a request for proposal, contains list of technical specification for equipment which is required, software and services needed. RFQ is a request for quotation, names desired items needed and asks for a quote. Evaluating bids. Most companies have procedure of evaluating bids benchmark tests so that they can get the optimized results. By spending less cost, they have the best output. Documentations, RFPs, RFQs, and vendor evaluation materials include RFP or RFQ sent to potential vendors, proposal proposals received. Those there are lots of vendors available who can perform this type of task, but who is the best feature they can develop within a minimum cost. And so the proposals are going to be received, documentation procedure produced during the evaluation of bids. Then we have system implementation. Now the new system is installed, tested, and made operational. Data migration from the previous to the new one or the upgraded one, system must be thoroughly tested. Test data should be realistic and include incorrect data. System conversion. One testing phase is completed, system is installed, direct conversion, old system deactivated and new system is immediately implemented. Parallel conversion. Both systems are in parallel conversion. Both systems are operated simultaneously until it is determined that the new system works properly, 100%. Guaranteed that the new system is okay. Phased conversion. System is implemented by module. So these are the system conversions ways. Pilot conversion, new system used at just one location within the organization, and if it does not it works properly, then it is deployed on all the remaining workstations. So pilot conversions, first they do the pilot testing, and then they deploy in the whole organization. User training, all training manuals should be developed and given to users. Training take place on the actual system, can occur one-on-one or in groups. Documentation, implementation, schedule, test data and results and training materials. Implementation, schedule, test data, test results, training materials should be saved for future references so that they can take the helps. So you can see old system and new system, direct conversions. Then parallel conversions, old system and new system both are working together. Old system and new system are both operated until it determined that the new system is working properly. Module 1, Module 2, Module 3, old systems and the phase conversion. The system is implemented by module. Each module can be implemented using either direct or parallel conversion. Either one by one, some features of old and new system has been replaced by the new system. Either both works parallelly, either they are directly replaced. Pilot conversion, old system, new system, site 1 old system, site, and then site 2, site 3 old system, and some PCs they have new system. The new system is used at only one location within the organization, and the remaining you can see overall old system is working. After it is determined that the new system is working correctly, it is installed at the other all locations. Then we have system maintenance. Maintenance is an ongoing process. Minor adjustments are made to the finished system to keep it operational until the end of the system's life or until that time that the system needs to be redesigned. Post implementation review identifies any glitches in the new system that needs to be fixed. When a major change is needed, the project goes through the SDLC again, the system development level. That what is the problem, where is the problem, how to, what type of programs we have to implement again. Then again, design, development, and testing phase. So we have to go again with the same SDLC life cycle. Documentation completed project folder. Results of the post implementation review are added to the accumulated documentation. Information can be useful to auditors who may check to see that proper procedures were followed. And the traditional approaches, as I have discussed, which is known as the waterfall model, system development phases are carried out in a preset order: preliminary investigation, system analysis, system design, acquisition, implementation, and then maintenance. This is referred to as the waterfall model. Each phase begins only when previous one is completed. Time consuming, the iterative approach, system is developed incrementally. Steps are repeated until the system is finalized. Prototyping, small model or prototype of the system is built before the full scale development effort is undertaken. So this is all. So you can see this is waterfall model, one after other, one after other, and one after other. This is prototyping alternate iterative approach. An iterative approach is in which a prototype is designed and developed and tested, and then an improvement prototype is developed and tested, and the process is repeated until the final version is reached. So the end user development approach. User is preliminary responsible for the development of the system. Most feasible when the system being developed in a small and inexpensive. Then we use this end user development approach. Measures must be taken to ensure that the system is compatible with existing systems and no new problems are introduced. So this is our entire system development life cycle.